Let's talk about something called visible light communication. What is it? Well, imagine getting your internet from a light bulb. It sounds a little wild, I know, but this is a real technology that could, quite literally, be hiding in plain sight. I mean, really think about that for a second. What if your internet connection wasn't coming from some router across the room, but from the actual lamp on your desk? It sounds like something straight out of a sci-fi movie, right? But this isn't some far-off dream. It's the core idea behind a technology that uses the very light we see to transmit data at incredible speeds. All right, so let's get right into it. What exactly is visible light communication? You'll often see it called VLC for short. So, at its heart, VLC is just another wireless technology. But here's the huge difference. Instead of using radio waves, like Wi-Fi or your cell phone does, it uses the visible light spectrum. Yep, the very same light that's coming out of an LED bulb. This is probably the best way to wrap your head around it. We all know Morse code, right? Dots and dashes, short and long beeps. Okay, now imagine that, but instead of sound, it's light. And it's flickering on and off so incredibly fast, we're talking millions of times a second, that your eyes can't possibly see it, but a device can. Each one of those flickers is a tiny piece of data. So how in the world do you turn a simple light bulb into a high-speed data transmitter? Well, it's not magic. It's all about a few key parts working together perfectly. Okay, let's break down the hardware. First, you've got your transmitter, which is just the LED itself. Then, on your device, you need a receiver. That's a tiny little sensor called a photodetector. Now, the real genius is in the driver's circuitry. That's the part that tells the LED exactly how to flicker to represent the data. And finally, you have a signal processing unit that takes that flickering light and decodes it all back into data your device can actually use. So let's walk through how it all comes together. First, the data, just a stream of ones and zeros, is sent to that driver circuit. Step 2, that circuit then modulates the light, making it flicker or dim ever so slightly to represent those ones and zeros. Next, the photodiode on your phone or laptop picks up these tiny changes. And finally, a processor turns those light patterns back into the original data. That's it. And this whole dance happens millions of times every single second. This diagram really shows the system in action. You can see how each of those LED lamps creates its own little data zone. They call it a VLC cell. It's like a bubble of light that's also a high-speed data hotspot. You can literally paint a room with a network, blanketing the whole space in connectivity. Okay, now for the big question on everyone's mind. We already have Wi-Fi, so why do we need this? What makes VLC a potential game changer? The differences here are actually pretty huge. So Wi-Fi uses radio waves. VLC uses light waves. What's the big deal? Well, for one, security. Radio waves go right through walls. That's why someone can sit in a car outside and try to hack your Wi-Fi. But light can't pass through a solid wall. So with VLC, your physical walls literally become your firewall. If you can't see the light, you can't get the data, period. Plus, the visible light spectrum is absolutely massive and free to use, unlike the radio frequencies that Wi-Fi has to fight over, which are getting more crowded by the day. So with these incredible advantages in security and bandwidth, where can we actually use this stuff? Let's look at where VLC really shines. The best-known application is probably Li-Fi, which stands for light fidelity. Just think of it as Wi-Fi, but deliver through light for insanely fast internet in places like offices or schools. In healthcare, it's a huge deal because light doesn't cause the same electromagnetic interference as Wi-Fi, which can be a real problem for sensitive medical care. And then you've got cars. The nearly instantaneous speed is perfect for vehicle-to-vehicle communication, for things like crash warnings that can make our roads way, way safer. And here's the kicker. We already have the infrastructure. I mean, look at this picture of a smart office. We already have lights in every room of every building. The whole point is that those same light fixtures that let us see can also become a high-speed, super secure network, connecting everything from your computer to your printer to your TV. So it really leaves us with a powerful thought. We are always on the hunt for more bandwidth, better security, faster connections. What if the answer has been hanging right over our heads this whole time? As our world demands more and more data, it's amazing to think that the very lights that guide our way could also become the network that connects our entire future.